All right, we're in part 3. So we are going to solve some equations which are all trigonometric in nature. So for the first one, I have a 2 cosine squared theta. And as I am doing these, I want to make sure that my arguments match. Okay, so the first thing I notice is that yes, all of my arguments match, and yes, I'm in terms of cosine. So I am going to go ahead and use just some u substitution just to make life a little bit easier. So I'm going to say that u equals cosine theta. And for all 4 of these equations, we're going to solve these on one lap of the unit circle, which is not what that is. So 0 is, and then that goes away. There we go. So my theta needs to be within one lap of the unit circle. So why did I do this u substitution? Because this looks scary, but this does not. Okay, so now I can factor this. So when I factor, I'm going to use grouping. So I need to multiply first and last, which gives me a 4u squared that is negative. I need 2 numbers that multiply to a negative 4 that add up to a negative 3. So I'll have a negative 4u and a positive 3u. Trash your negative 3u and put those 2 in its place. So I've got a 2u squared minus a 4u plus a 3u minus 2 is 0. Do not simplify or you'll end up right back there. And now do factoring by grouping. So on the first 2, I can factor out a 2u, which leaves me with a u minus 2. On this one, pause. No idea what I was thinking. This is not a 3. This is a 1. This is not a 3. This is a 1. Because negative 4 plus 1u, negative 4 plus a u is negative 3u. Negative 4 times a positive u is a negative 4u squared. I was going, this is not factorable. All right, so what's common here? Nothing. So pull out a positive 1. Because I can always divide by 1 and not change what it is. So what is in parentheses, which means you are factoring out a common factor. What is not in parentheses, which means that is what is left. And now take each factor, set it equal to 0. So u minus 2 is 0, so add 2. And then 2u plus 1 is 0, which means u is going to be a negative 1/2. Because I would subtract 1 divided by 2. But remember, I don't care about this because these are all cosines. So where does cosine equal 2? Within one lap of the unit circle. And then where does cosine equal negative 1/2? In one lap of the unit circle. Well, cosine doesn't equal 2. That's outside of the range of cosine. So I'm going to have 2 answers. One is 5 pi over 6. And one is 7 pi. Oh my gosh, those are both wrong too. Sorry. This one is 2 pi over 3. And this one is 4 pi over 3. Good heavens. I'm trying to race through these things, and yet I'm not doing a very good job. Okay, so the next one is, I have, hang on, I've lost the next one. Cotangent of 4 theta minus 1. So cotangent of 4 theta minus 1 is 0. I've got one trig function. Its argument matches itself because it's 4 theta. So I can just solve for this. I'm going to add 1 to both sides. So the cotangent of 4 theta is going to equal 1. So basically what you're going to answer is, where does cotangent have a ratio of 1? And I'm going to end up dividing by that 4. Okay, and I need all representations within one lap of the unit circle. So I'm going to just say, okay, what if this was just a single theta? Where does cotangent equal 1 in a single lap of the unit circle? And that is going to happen at my theta at pi over 4, and then again at 5 pi over 4. So that's where cotangent has a ratio of 1. Now what we need to do is do a couple more iterations. So I'm going to take pi over 4 and add a lap. So I'm going to add 8 pi's over 4. So that gives me 1 pi over 4 plus 8 pi's over 4 is 9 pi's over 4. Do it again to this one. So 5 pi's over 4 plus 18 pi's, or sorry, 8 pi's over 4 gives me 13 pi's over 4. And then just for kicks, let's do it one more time. And so a pi over 4 plus, now we've got to do 2 laps, so that's going to be 16. So this gives me 17 pi's over 4. And then I'm going to add 16 to this one, so I get 16 and 5 is 21 pi's over 4. And then maybe we should do, hang on, I'm thinking, we should probably do one more. actually, let's see what we got. What we normally have is just a single theta, and that's what would occur. And you're like, but everything but these two are in one lap. Those aren't. But here's where the fun comes in. I don't have a single theta. I got a 4 theta. So what I need to do is divide everything by 4, which means my denominators change to 16s. Okay, so I have pi over 16. And this is where we may need to add another iteration. I've got a 5 pi over 16. I've got a 9 pi over 16. I've got a 13 pi over 16. I've got a 17 pi over 16. Okay, so I'm still within one lap. I just got past pi, which is 16 pi's over 16. Okay, on this one, hang on, I've lost control. I've got 21 pi's over 16. So 32 pi's over 16 will be a full lap. So I probably need to do one more iteration. So I did 8 pi's over 4. I did 16 pi's over 4. Now I need to do 24 pi's over 4 because that reduces to 8 pi's. Or a lap, and third lap. All right, so if I'm going to add 8 pi over 4, then 16 pi over 4, and then 24 pi's over 4 is where I'm at. So this is 25 pi's over 4, which will give me 25 pi over 16. And this is going to be 24 plus 5 is 29 pi's over 4. Oops, sorry, over 16. Because we're going to end up dividing by that 4. So if I do another iteration, I'm going to be over 32. So those are all the places, if cotangent is 4 theta, that I will have it equal to 0. Okay, so let's do another one. I have the cosine of 2 theta. So cosine 2 theta plus 6 sine squared theta equals 2. And one of the first thing I notice is that my arguments don't match. This is a 2 theta, that's a 1 theta, and my trig functions don't match. So what I probably want to do is focus on him, because this is a single theta. And so that's going to be easier to deal with. So let's look at the cosine of 2 theta and see if we can match it up with some sine squareds. So the cosine of 2 theta, oh, look at that. It does match up with a 1 minus 2 sine squared theta. So I'm going to replace this with a 1 minus 2 sine squared theta plus 6 sine theta equals 2. And now I'm going to combine some like terms. Oops, he squared. That would have been bad. All right, so 6 of those minus 2 of those is 4 of those. So I've got 4 sine squared theta. Okay, and I'm going to subtract 1. So I end up with 1. So I added these together to get a 4, and then I subtracted 1 to get a 1. So I am now going to divide both sides by 4. So I get a 1/4, and then I'm going to take a square root, which means where does sine in one lap of the unit circle have ratios of positive or negative root 2? Well, sorry, positive or negative 1 over 2. Square root of 1 is 1, square root of 4 is 2, and don't forget your plus minus when you're taking roots. So where in one lap of the unit circle does sine have positive or negative ratios of 1/2? That's going to happen at pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. All right, so the next problem is we've got sine squared theta plus 5 or equals 5 times the cosine of theta plus 1. And I notice, first of all, that both of my arguments match. That makes me happy. However, my trig functions don't match. And so as soon as I see a sine squared, I immediately head towards Pythagorean identities. And I realize I can rewrite sine squared as 1 minus cosine squared theta, and then distributing on the right, I've got 5 cosine theta plus 5. So I'm going to bring everything to the right. My squared term is negative, so I'm going to push everything to the right. So I'm going to subtract 1, add cosine squared, and in the process of this, I'm going to put this in descending order. So I have a cosine squared theta. I have a positive 5 cosine theta, and then I have a plus 4, and that needs to equal 0. So again, if it makes you happier, you can say, all right, u is cosine theta. So now what I have is a u squared plus a 5u plus 4 is 0, which factors down to u plus 4 u plus 1 is 0. And then u must equal -4, or u must equal -1, which means cosine theta would be -4. Cosine theta would be -1, because I'm going to back substitute there. Well, -4 is outside the range for cosine, and so that's not going to work. That's extraneous. This one, where does cosine theta equal -1? Theta will be pi. Okay? So now we're going to grab some unit vectors. I have vector v is 2.1i minus 1.4j, and then plus 4.2k, and then vector w is going to be -3.4i, and hang on, I've lost it. Sorry. Plus 5.8j and minus 2k. Okay, so question number 1 is, would you please find a unit vector that is parallel to v? So remember, a unit vector, if it's parallel, it just means it's a scalar multiple. Okay, so if I find the unit vector, by definition, it will be parallel, and it will just have a magnitude of 1. So I'm going to take 2.1 on I minus 1.4 on j plus 4.2 on k, and I'm going to find the magnitude of v. So the magnitude of v is going to be a 2.1 squared plus a 1.4 squared plus a 4.2 squared. So when I find that magnitude, I've got the square root of 2.1 squared plus 1.4 squared plus 4.2 squared. And when I do that, I get a 4.9. So my magnitude is 4.9. So I'm going to take each component and multiply it by the scalar of 1 over 4.9. So this is now a scalar multiple of my original vector, so by definition it's parallel. All right, and it's a unit vector. So do that mess, and now my final answer for this is I'm going to see if these reduce, because these are all multiples of 7. So I've got a 2.1 divided by 4.9, and I hit math, enter, enter, and I find out that that is, piece of crap, this is 9, and I get 3/7. Okay, so I have a 3/7 on I. So my unit vector in the same direction and parallel. So same direction is parallel, but it's a unit vector. And then I'm going to have a minus 2/7 on j, and I'm going to have a plus 6/7 on k. All right, so the next thing I want is a vector orthogonal to both v and w. So a vector that is orthogonal to both vectors means I need to find the cross product. So to find my cross product, I'm going to have an I, a j, and a k across my top row. So what I'm finding is the cross product, that's not cross product, of v and w. So v is going to go first, not that it matters, but v is going to go first. So I got a 2.1, a negative 1.4, and a 4.2. W is going to go second, so negative 3.4, 5.8, and negative 2. So I want to find the cross product. So if I want I, cover it up. So I've got negative 1.4 times negative 2, and I'm doing this in the calculator, times negative 2 is minus 5.8 times 4.2 gives me negative 2156. So I've got a negative 2156 on I. Okay, remember to change your sign on j. So hang on, I think I just entered that wrong. I have this one negative, and that's positive, and positive. Okay. All right, so on this one, I'm going to cover up j. So I get a 2.1 times a negative 2. And then I'm going to subtract a negative 3.4. So I'm going to add 3.4 times 4.2, and I get 10.8. 10.08. So remember, you change the sign. I got a positive answer in my calculator, but on J, you change the sign. And then if I want K, cover it up. So 2.1 times 5.8 is, and then minus a positive number is going to be minus 3.4 times 1.4, which gives me 7.42. So this is a vector that is orthogonal to both of those, okay? And it's normal to the plane that contains those two vectors. All right, finally, I want to find the vector between V and W. So the vector between V and W is going to be found by the cosine of theta is the dot product between the two divided by the product of their magnitudes. And then I'm going to take the arc cosine of both sides. So if I take the dot product, recognizing I just rewrote here, it's going to be easier for me to just multiply these together, and these together, and add them all up. So 2.1 times negative 3.4 plus negative 1.4 times 5, that's not 5, 5.8 plus 4.2 times negative 2. And I get that, and assuming I've typed everything in correctly, negative 3, 4, negative 1, 4, 5, 8, 4, 2, negative 2, I get a negative 2366. So my dot product gives me a negative 2366, and then I'm going to have the product of their magnitude. So the magnitude on V is going to be the square, actually let's not do that, is going to be 2.1 squared plus, let's turn that off so you can see better. Maybe not. All right, so 2.1 squared plus 1.4 squared, that's not squared, delete, 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 squared. All right, plus 4.2 squared is, so that's 2401. And then my dot product, or sorry, my magnitude on W is going to be 3.4 squared plus 5.8 squared plus 4. Okay, and I get 49.2. So that is my answer from here. This was just the formula. I'm going to take the arc cosine of both sides. So I end up with theta is the arc cosine of negative, can you see? Why is this so bright today? I don't think I know. Okay. So the arc, there's, all right, so negative 23.66 over the square root of 2401 times the square root, which we could have left it underneath the same radical, of 49.2. And we get 2.33. So that is the angle measure. Wait a minute. Mode. I was in radians. Trash. All right, hang on. Quit that out. Come back up here. And I get 133.5. 133.5 degrees. All right, so that takes us through number 15. All right, so we've got a good stopping. All right, I just dawned on me I didn't show you the completed problem. So we're going to autofocus that thing. Okay, so I did the arc cosine of this and made sure I was in degrees, and I got 133.5.